Hello everyone and welcome back to ImTechnos. In today's video, we are going to understand what Amazon SageMaker is with a hands-on demo. As usual, let's start with a simple scenario. Assume you want to build a machine learning model, not just build it. You want to train the model, deploy the model, and monitor the model. But in reality, before you even start building a machine learning model, you need many things like servers, GPUs, Python libraries, scaling, monitoring, and much more. In simple words, you first need infrastructure. Now, even if you choose the cloud and use AWS services like EC2, the work is still not simple. You need to launch an EC2 instance, install Python, install libraries like TensorFlow or PyTorch, manage scaling, and handle failures. For users who are doing for the first time, this process is not beginner friendly at all. So this is where Amazon SageMaker becomes useful. Amazon SageMaker solves this problem by providing ready-to-use tools, automatically handling infrastructure, and offering both visual and code-based options. Using SageMaker, you can build machine learning models, train them, deploy them, and monitor them without managing any servers. So in simple terms, SageMaker simplifies the end-to-end machine learning lifecycle. Now let's understand how SageMaker works at a high level. The workflow is very simple. First, we create our dataset locally. We make sure we have the required data for training. This dataset can be a CSV file or any supported format. Next, we upload the dataset into S3 bucket. Why? Because Amazon SageMaker does not read data from our local system. It always reads training data from S3. So we upload the dataset to an S3 bucket and SageMaker will access it from there. Now we create a training job in SageMaker. During this step, SageMaker reads the training data from S3. We select a built-in algorithm and the training process begins. When we create a training job, SageMaker automatically launches a temporary EC2 instance in the backend, downloads the dataset from S3, trains with the data using the selected algorithm, stores the trained model artifact back to S3, and terminates the temporary instance after training completes. So everything is managed automatically. You don't have to manually create or stop EC2 instances. Now, once the training job completes successfully, we create a model. This model simply links to the trained model artifact stored in S3. So creating a model does not mean running it. It just registers the trained artifact along with the required container and permissions. So think of it as preparing the model for deployment. Next, we create an endpoint configuration. Here, we define which model to use, which instance type to use, and how many instances to run, like the instance count. So think of this as a deployment blueprint. At this stage, nothing is running yet. We are only defining the configuration details. Finally, we create the endpoint. So when we create the endpoint, SageMaker launches EC2 instances in the backend, loads the model, exposes it as an HTTPS endpoint. Now the model becomes live and ready to receive a request. And yes, billing starts once the endpoint is running. Once the endpoint is successfully created, we can invoke the endpoint, send test data, and receive predictions. So this completes the full workflow. So here, your responsibility is only what to build, and AWS takes care of how it runs. Now let's move on to the hands-on demonstration of Amazon SageMaker AI in the AWS Management Console and implement everything step by step. First, we'll start with the training dataset. In this example, we want to predict whether a student will pass or fail based on the number of hours studied. If a value is 1, it means the student has passed. If a value is 0, it means the student has failed. So our dataset looks like this. If a student studied for 6 hours, he passes. If a student studies for 7 or 8 hours, he also passes. However, if a student studies for 1, 2, or 3 hours, he fails. So what we are trying to model here is a simple rule. If a student studies more than 5 hours, he passes, which is 1. If a student studies less than 5 hours, he fails, which is 0. Now let's understand the format of this dataset. The format is a label and feature. Okay, so the first column is the label, pass or fail. And the second column is a feature, like the number of hours studied. Okay, now please understand that there should be no headers, There should be no empty rows, only 2 columns, only numeric values. Make sure everything is clean before saving the file. Okay. Now save this data set as trainingdata.csv and keep it in a folder on your system. Now I'm in the AWS Management Console. For this demonstration, I will be using Mumbai region, which is Asia Pacific AP South 1. Okay. Make sure you're also in the correct region before proceeding because all the resources must be created in the same region. Now the first step is upload our training data set to an S3 bucket. So in the search bar, type S3 and select it from the list. Now we are in the S3 console. Here, we will either create a new bucket or use an existing one if you already have any. So for this demo, we will create a new bucket. Make sure you are in the correct region. Okay. For example, I'm using Mumbai region, which is AP South 1. You can use any region, but ensure you stay consistent throughout this demo. Now provide a unique bucket name. For example, my SageMaker demo bucket. To make it unique, I'm just giving 18 to 26. Keep the remaining options as default and click create a bucket. Now, once the bucket is created, open the bucket, drag and drop your training dataset file and click upload. Now, our training dataset is successfully stored in S3. Now, before creating the training job in SageMaker, we must ensure the required instance type is enabled. In a new tab, search for service quotas and select it from the results. Now, under manage quotas, search for SageMaker and select it and click view quotas. Now, once the list loads, search for ml.t3.large. Now, from these options, choose ml.t3.large for training job usage. Okay, make sure you choose the correct option and click on request increase at account level. Now change the value to 1 and click request. Usually, if you request an increase from 0 to 1, the approval is almost immediate. However, if you request a higher value like 3 or 5, it may go for manual approval and take more time. So my account already has a value set to 1, which I have done previously. So I'll skip this step. Now open a new tab and search for SageMaker. You may see 2 options, Amazon SageMaker and Amazon SageMaker AI. So make sure you select Amazon SageMaker AI because we are going to build, train, and deploy a machine learning model. Now, once you're inside an SageMaker AI dashboard, in the left navigation, under model training and customization, click training and tuning jobs and click create a training job. Now let's configure it. So under the job name, I'll give the name like demo linear learner. Under IAM role, click create new role. Select any S3 bucket and click create role. Okay. Now this allows SageMaker to access the training data from S3, store the model artifacts back in S3. Under algorithm selection, choose Amazon SageMaker built-in algorithm. And from the drop-down, choose tabular linear learner and keep input mode as file and metrics as default. Now under resource configuration, choose instance type as MLT3 large. So why do we need an instance type? Because SageMaker uses backend compute infrastructure to train the model, as we discussed in the slide. Yeah. Now, without enabling the instance quota, the training job cannot run. So keep the instance count as 1, volume size as a default, and maximum runtime as 1 hour. And then we have hyperparameters. So these are the settings that control how the model learns from data. They are not learned automatically. We must set them manually. So first we have feature underscore DIM. This parameter tells the algorithm how many input features does each training record have. So in our data set, we have only 1 input column. Okay, the other one is output. So we have only 1 input column. We set the feature underscore DIM as 1. So always make sure this number matches the number of input columns in your dataset, excluding the label column. Next, we have mini batch size, and this is very important. This parameter defines how many training records are processed at one time before updating the model weights. In our training dataset, we have 10 rows. So the mini batch size must be less than or equal to 10. If you leave the default value, which is 1000, and your dataset has only 10 rows, the training job will fail. So that's why we are setting mini batch size to 5. So if we keep this mini batch size as 5, for the first 5 rows, the model updates weights, and the next 5 rows, model updates weights again. So the entire dataset, which of 10 rows, is completed in 2 batches. So why not to keep mini batches as 10? You could set it to 10. That means the model processes all rows at once in a single batch. However, we usually keep batch size smaller than the dataset size because it improves learning stability, it updates weights more frequently, and it helps better generalization. So the thumb rule is mini batch size must be always less than or equal to the total number of rows. So if the batch size is larger than the dataset size, the training job will fail. So since we have 10 rows, keeping it as 5 is safe and a good choice. Now let's talk about the predictor type. So this defines what type of machine learning model are we solving. In our case, the output is either 0 or 1. For example, if a student studies more than 5 hours, it's a pass, which is 1. If less than 5 hours, fail, which is 0. So we are dealing with 2 possible outputs, 0 and 1. This is called binary classification. So therefore, we select the predictor type as binary classifier. If you had more than 2 classes, you would choose multi-class classifier. If you are predicting continuous values like marks, salary, or temperature, then you would choose regressor. But in our case, since it is 0 and 1, we select binary classifier. So at this point, we are good with the hyperparameters. We can keep the remaining settings as default. Now let's configure the input data. For the channel name, we will keep it as a train. Under the content type text /CSV because we uploaded a CSV file into the S3 bucket. For input data source, keep S3 selected. Go to your S3 bucket, select the uploaded file, copy the S3 URL, paste it back in the SageMaker. We will keep the checkpoint configuration as optional. So coming to the output data configuration, when we click create training job, what happens is the SageMaker will train the model and generate something called as model artifact. That model artifact must be stored in an S3 bucket. So under output data configuration, we will provide an S3 bucket path where the model artifact should be stored. So I'm choosing the same bucket we created for the training dataset to store the model artifact. With these options, click create training job. It takes a while for the job to complete. Make sure that both the job status and the job secondary status change to completed before proceeding to the next step. So job status shows the main lifecycle state of the training job. Common values include in progress, completed, failed, and stopped. And job secondary status shows the detailed internal stage of the job while it is running. It provides more granular progress information. And common values include starting, downloading, training, uploading, and completed. So if the job is successfully completed, then everything is fine. Okay, you can skip the troubleshooting section and move on to the next step. However, if the job fails or you encounter the error, click on the job name to open it and view the error details. If the error message says something like SageMaker is not authorized to perform S3 get object on your S3 bucket, which is shown on the screen, it means that the SageMaker is trying to read the training data from S3, but the IAM execution role does not have permissions to access that file. So this is not an issue with your dataset or the algorithm. It is simply a permissions issue. To fix this, go to IAM role, open the execution role that was created for the training job, attach the Amazon S3 full access policy because it is just for demo, and save the changes. Once a training job fails, you cannot rerun the same job. Instead, you need to clone the failed job, ensure the correct permissions are attached, and then create the training job again. After that, the job should run successfully. Now let's look at another common error you might encounter. If you see a failure reason that says unable to read data channel train, requested content type is application /s record IO hyphen protobuf, please verify the data matches the requested content type. So this error indicates that the SageMaker is trying to read your training data using a specific format called application /x record IO hyphen protobuf. However, your actual file is not in that format. In our case, we uploaded a CSV file. So this is a data format mismatch error. Again, this is not a problem with the algorithm and it is not a permissions issue. It simply means that the content type selected in the training job does not match the actual file format. So how to fix it? Go to your failed training job, click on clone. Under input data configuration, change the content type to text /CSV. Make sure the S3 path is correct and click create training job. After making this change, the training job should run successfully. Let's examine the next failure scenario. On the screen, if you see the message, unable to parse CSV rows 1 to 1000 or sometimes rows 1 to 5, it also shows the path of the dataset that we uploaded as input. This error tells us that SageMaker was able to access the file successfully, permissions are fine, the content is also correct. However, SageMaker could not read or interpret the CSV file properly. So this is data formatting issue inside the CSV file. If you encounter this error, it usually means one of the following. The CSV file contains a header row. There are empty rows in the file. Some rows have missing values. There are extra commas or inconsistent columns. Or the label column is not in the expected position. For built-in algorithms like linear learner, SageMaker expects no header row, only numeric values, the same number of columns in every row, and the label column in the correct position, usually the first column. If any of these conditions are not met, the training job will fail with a parsing error. So how to fix it? The solution is simple. Open your CSV file, make sure it contains only 2 columns, 1 input feature and 1 output label. Ensure all values are numeric. Remove any header row, remove any blank lines. Make sure there are no extra commas. Ensure every row has the same number of columns. After cleaning the file, save it, uploaded the updated file to S3. You can replace the existing file and go back to SageMaker, clone the failed training job and create a training job again. It should now work successfully. Here is one more common failure case. If you see an error that says no training data processed, either the training channel is empty or the mini batch size is too high, this error indicates that the SageMaker started the training job, but it did not process any data. There are usually 2 main reasons for this. One of the reasons could be SageMaker could not find or read any training data. This can happen if the S3 path is incorrect, the file does not exist in the bucket, or the file exists but it's empty. To fix this, go to your S3 bucket, verify the file exists, open the file and confirm that it contains data. Make sure the S3 URL in the training job is correct, because even a small mistake in S3 path can cause this error. The second possible reason is that the mini batch size is larger than the number of training records. You remember this rule? The mini batch size must always be less than or equal to the number of training records. For example, if your dataset contains only 10 records, but the mini batch size is set to 1000, the training job will fail. In our case, since we have 10 records, we can safely set mini batch size as 5. So how to fix it? Clone the failed training job, go to the Hyperparameters section, adjust the mini batch size to the value smaller than the number of records, create the training job again. After making these corrections, the training job should run successfully. Now, as you can see, my job is successfully completed. Now let's create a model. To create a model, first select the training job that has been completed successfully. Then click on Actions. Choose the third option, which is Create a Model, and click on it. Now provide the model name, for example, a demo linear model. Next, choose the same execution role that we created earlier. You will notice the most of the other options are already pre-selected. This is because we are creating the model directly from the completed training job. So SageMaker automatically fills in the required details. So you just need to provide a model name and select the appropriate execution role. Then click Create Model. Okay, now that the model has created successfully, it's like instantly. Until now, we have completed the training process. First, we created the training job that trained our data. Then we created a model, which essentially packages the trained model artifact along with the required container and permissions. Now we are going to create an endpoint configuration and deploy the endpoint. So select the model that we created earlier and click on Create Endpoint. Now provide an endpoint a name, for example, demo linear endpoint. Since we don't have an existing endpoint configuration, we will create a new one. So in this step, we are creating both the endpoint configuration and the endpoint. Okay. So give a name to the configuration. For example, demo linear endpoint config. Under deployment options, select provision. We are not enabling encryption for this demo. Under variants, you will see an instance type is already selected. Scroll to the right and click Edit. Now choose the smaller instance type to reduce the cost. For example, MLT2 medium. Keep the remaining settings as default and click Save. So we are not creating any additional production variants or shards. Now click Create Endpoint Configuration. So before creating an endpoint, SageMaker requires us to create an endpoint configuration. So this configuration defines the instance type and deployment settings. So remember, the endpoint configuration acts as a blueprint. So after the configuration is created, click Create Endpoint and do a refresh. The status will show as creating. So when you click Create Endpoint, SageMaker allocates the EC2 infrastructure, pulls the inference container image from ECR, downloads the training model from S3, loads the model to the memory, and creates an HTTPS endpoint. Only after all this, the status will become in service. So let's wait until the status changes to in service. This usually takes 3 to 5 minutes. Okay. And one very important thing to understand is that billing starts immediately once the endpoint becomes in service. So you are charged per hour based on the instance type you selected. So even if you do not send any request, the instance continues running and you will still be billed. So always remember to delete the endpoint after testing to avoid unnecessary charges. Now the status is in service state. Let's test the endpoint. Click on the endpoint that we created. Here you will see the HTTPS URL. Okay. So this is the runtime endpoint URL that SageMaker generated. This URL is meant to be used by applications, SDKs, backend services, tools like curl or Postman with proper authentication. It is not meant to be opened directly in the browser because it requires authentication, it expects a post request, and it expects input data in the request body. So in the new SageMaker console, there is no built-in test UI for some endpoints. So we are using the AWS CLI to send input data to our deployed SageMaker endpoint. Remember how our model was trained? The first column in the dataset was the label, and the second column was the feature. So when sending an input to the endpoint, you only send the feature value, not the label. For example, if a student studied for 6 hours, you would send 6 as the input. The output will look something like 0.7. This 0.7 value represents the probability of class 1, which in our case means pass. If the value generated by model is greater than 0.5, the model predicts pass. If the value is less than 0.5, the model predicts fail. In the top navigation bar, click on Cloud Shell. Wait for the environment to initialize. Once the terminal is ready, paste the CLI command. If it asks whether it is okay to paste multi-line text, click OK and press Enter. The command calls the SageMaker runtime service, specifying the endpoint, sends the value as 6 in CSV format, and saves the prediction output into a file. And the extra flag for binary format is required in the AWS CLI version 2 to handle raw input correctly. After executing this command, run cat output.txt. Oh, my bad. So cat output.txt. You should see a score such as 0.7049. This means the SageMaker successfully trained the model, the endpoint was deployed correctly, the model is able to process input and return predictions. And this confirms everything is working as expected. So that's how we train, deploy, and test a model using Amazon SageMaker. In the next step, we will discuss how to clean up resources properly to avoid charges. First, close the Cloud Shell. Then go to the endpoint page, which we are into. On the right-hand side, click Delete and confirm the deletion. This step is very important because the endpoint is the resource that incurs ongoing charges. Next, in the left navigation panel, under Deployment and Inference, go to Endpoint Configurations. Select the configuration we created. Go to Actions, click Delete. Confirm the deletion. Under the same section, click Deployable Models. Select the model we created. Go to Actions and click Delete and confirm the deletion. Now, under Model Training and Customization, click on Training and Tuning Jobs. Here, you will see the training job that we created earlier. Please understand, there is no delete option for the training job, and that is completely fine. When we created the training job, SageMaker temporarily launched an EC2 instance to train on the data, and once the training was completed, that instance was automatically terminated. So there is no running infrastructure associated with the completed or failed training job. That means you are not charged for keeping the training job listed here. And lastly, go to S3 console, delete all the objects in the bucket by providing the necessary prompt. Then delete the bucket by specifying its name. So this covers the complete process of training, creating, and deploying a model using Amazon SageMaker. That's it for today. If you have any questions, feel free to drop them in the comments below. Thank you for watching, and I'll see you in the next video. Take care and happy learning.